Hey grade 7s! I hope you guys are doing well and you've enjoyed your weekends and hopefully enjoyed some of the nice weather that we've been having and got to go outside. Today we are starting up our new unit. We're going to do a little bit of a review of similar triangles, and then we're going to go into our new unit, which is on integers. So today's lesson is actually going to be a little bit of a review. Somewhat new, but mostly review from when we did the coordinate grid back in, I believe it was January, February. So today's lesson is going to be pretty easy. So first of all, we're going to do our review. So are the triangles below similar? So what are the two different ways we can find similar triangles? Is by putting them into fractions, so matching the sides up, and then putting them into fractions and reducing the fractions as much as possible. Or we can look at our multiplication. Today I'm just going to do fractions. So I'm going to match up my sides. How do I know which sides to match up? Well, first of all, I can tell because of the numbers. Because the numbers are designed to make it look somewhat similar. As in, the longest side of this triangle measures 12, the longest side of this triangle measures 6. So I know these are matching because they're both the longest sides of the triangle. The shortest sides I can also figure out pretty easy because 3 is the smallest of this one and 7 is the smallest of this one. Next up is 10 and 5, and those are already done. So how do I figure out if they are similar? Well, let's put them into fractions. So I'm going to do 6 and 12 in green. 6 over 12. Can I reduce it? Yes, because if I divide both of them by 6, I can get 1/2, because I know 6 is half of 12. So that's one fraction down. The next one is 3 and 7. I'm going to do that in purple, pinkish color. 3 over 7. Can I reduce this any more? Nope, because the only number I can divide by 3 or 7 is by 1 or itself, and it will not work. Next is 10 and 5, so I have 5 over 10. I know that 5 is half of 10, so I know I can just reduce this into 1/2, or I can just divide both by 5. And that equals 1 over 2. So I have two sides that are matching that are 1 over 2. However, I have this outlier here. Does that mean that these triangles are similar? No, because even if I have this one outlier side, it means this triangle is completely different from the other. Okay? So they all have to match up. They all have to have an equivalent fraction, or they all have to be multiplied by 2 or 3 or something along those lines. They're all 2/3 and they're all reduced to the same number. If one of them doesn't reduce and one of them doesn't fit with the other two, it doesn't matter. It's not a similar triangle. Okay. Now, we're going to go into integers. Intro to integers. So who remembers our coordinate grid? Remember when we were plotting things on there? You're plotting, 2, 3. You go 1, 2 over and 3 up. And you plot, you plot a point on there. So 2, 3, and you plot a point, and that would be like point A. And we plotted different points on there. So you guys already know quite a bit about integers because we already did the coordinate plane. Integers are basically another name for numbers. But what's special about integers is it's named for numbers that can be positive. No, don't want to do that. It can be another name for integers that are positive, or name for numbers that are positive, but also a name for numbers that can be negative. So that's really all integers are, is it's a name for numbers, but they can be positive or negative numbers. Today we're going to talk about representing integers and the different ways you can represent an integer. And I will give you an example what I mean by that. So if I give you the number, once I erase this, if I give you the number -2, all on its own, there's 3 different ways I can represent -2. One is numerically. So usually if you have a negative number on its own, they're often in brackets. The reason being is because if I put this in brackets versus this could just look like -2. So if I have a number here, it looks like 5 minus 2, where if I have this here, this could be 5 plus -2, or it could be 5 minus -2. That's why there's usually a little bracket in there, just to make it a little less confusing. So if I'm representing an integer, I want you to get into the habit that if you have a negative number, put it in brackets. So if I tell you -3, you do -3 and you put it in a bracket. So that's one way, is numeric. Okay, I can represent an integer by just a number. Pretty easy. The next is on a number line. So remember the coordinate grid, we had a x-axis that went side to side. 0 was always in the middle, and we went 1, 2, 3, 4, 5, and we would go on forever sometimes. -1, -2, -3, -4, and -5. And remember, we started out from 0 and went 1, 2, 3, 4, 5. So this way we went in order, but this way we had to actually go backwards because of the way that negative numbers work. So the next way I can represent an integer is on this number line. So a number line is basically just our x-axis of our coordinate grid, remember? Our x-axis went side to side, and we always use that one first. There's a reason. It's because it's a number line. So to represent a number on a number line, you would probably remember from like grade 2, oh, I want to put 3 on a number line. Oh, there's 3. So now we're going to talk about representing an integer on a number line, which is basically the same process, except you just have to make sure your number line extends beyond 0 as you go into your negative numbers. So usually 0 would be in the middle, and you go 1, 2, 3, 4, 5 to the right, and then -1, -2, -3, -4, -5 on the left. So -2, I'm going to represent that on the number line by basically drawing a number line and circling where -2 would be. I want to represent -3 on a number line. I draw my number line and I represent where -3 would be. So you guys are going to be pros at this because you're used to seeing a number line like this because of our coordinate grid. So that's our next way, is a number line. Our last way is by using counters. So you might remember using like little coin counters to add numbers together when you're in primary. So remember you had like a bunch of different counters and you want to do 17 plus 8. You have your counters, 17 is one pile, 8 counters in another pile, and you basically count all the counters together. This is similar, except right now you have colored counters, and the colors matter. Red counters, red counters mean negative. So if I'm trying to represent -2 by using counters, I would use 2 red counters. What if I'm trying to represent, let's do another number here, if I'm trying to represent +4. So I have 4, sometimes you'll see a positive sign in front of the number like this. This just means +4. You don't see it as often as you see it with the negative brackets, but you do sometimes see this. So when you see a bracket with a positive number and a positive sign and a number, it just means that's +4. Okay, it doesn't mean +4, it means +4. So I have +4, I'm going to represent on my number line as 4. How do I represent a positive number with counters? You use blue. So blue counters mean it's a positive number. Okay, so we have red as negative. down here, and then I'm going to represent positive 4. So I have 1, 2, 3, 4 blue counters. And if I have a negative number, let's say I did -5, I could represent that as 1, 2, 3, 4, 5 red counters. And there you go. So today what you're going to have is I'm going to give you a bunch of integers, and you're going to try to represent them in 3 ways. By a number line, counters, and numeric. You will have a Google form available to you. What I want you to do though, because you obviously can't draw red counters on a Google form document, you can just write, let's say the number is -5, you can just write 5 red counters. But make sure you identify the color, because that's important, because I know that if you got the color right, that means I know you understand that it's a negative number and it needs to be red counters. Or a positive number needs to be blue counters. A number line also cannot be represented on a Google form. However, the question will have a number line posted with it. What you can do to tell me where the number is located on the number line, let's say -2, you could say between -1 and -3. So if I'm trying to represent -2 and I'm using the Google form, I'll just say between -1 and -3. And that's what you can do to answer. That's only if you're using a Google form. If you're using a pen and paper, obviously you can just draw out a number line and like circle the numbers on there. The choice is yours on which method you prefer. So that's part 1 of what you're doing today, is just representing the integers. Pretty easy, I should think. I don't think any or too many of you would have trouble with it. The next part we're doing is recognizing greater or less than integers, as in the value of an integer. So I'm just going to erase this. Okay, so we are looking at greater or less than integers. So let's say I give you the numbers -3 and -7. Which one has a greater value? Which one is a bigger number? Now, some of you might instinctively think, oh, 7, because 7 is bigger than 3. However, it's actually the opposite way around with integers. And let me show you. So we have our number line. 0's in the middle. 1, 2, 3, 4, 5, 6, and 7. 1, -2, -3, -4, -5, -6, -7. Now, you might automatically think, oh, 7 is a bigger number. But with integers, the opposite is true. And let me demonstrate with you with the number line. -7 I can represent right here. I found this on the number line, and -3 is right here. The number that has the greatest value is actually the one that's furthest to the right. So between these two numbers, whichever one is further to the right on the number line, it has a greater value. Because think about it with positive numbers. If I give you the numbers 2 and 5, there's 2 and there's 5. Which one's further to the right? 5. 5 has the greater value. And you know that automatically that, oh, 5 has a bigger value than 2. So it's whichever number is further to the right on a number line. However, what if you're dealing with really big numbers, like -127 and -117? I'm not going to draw a number line all the way up to 127. It takes way too long, and there's no way to have enough paper to do that, or a long enough piece of paper to do it. How to tell with bigger numbers, whichever one is of a greater value, with integers, It's a little bit opposite. Usually it's the smaller number. So 117 is smaller than 127. The reason being is because 117 is closer to 0 than negative 127. Okay? So if I have negative 127 on my number line and negative 117, this is going to be closer to 0 on a number line automatically. And it has a lower, it looks like a smaller number, but it's actually worth more. Think about it this way. If I owe someone money, would I rather owe them $127 or $117? I'd rather owe them $117 because I owe them a little bit less that way, right? Think about it as like, oh, -7 and -17. I would rather owe $7 than $17 because I don't owe as much. So that's one way to think about it. The other way is with temperature. Would you rather be -7 degrees outside or -3 degrees? You prefer -3 because that has a higher value. It's a little bit warmer than -7 would be. Okay, so that's going to be part 2 today. Is you're going to have two integers, so like let's say -3 and -7. You're going to use your greater than or less than symbol. So remember the wide opening, it means the bigger side, so this means bigger. If they're equal, then you just use an equal sign. Another note, a positive number is always going to be worth more than a negative number. So if I have the numbers -2 and 5, the positive number is always going to be worth more. Just a reminder, your positive number may not have a plus sign in front of it. If it does not have a plus sign, it just means it's a positive number. The plus sign is just invisible. But your negative number will have a negative sign in front of it. Okay? So that's what you're going to be doing today, is representing the integers in 3 ways, and then greater than or less than. And that's it. So it's going to be a pretty nice, easy intro today. I think it should go fairly well. Email me if you have any questions whatsoever. I'm going to try to make those of you who use the Google Docs, or use the Google Forms, I'm going to make it as user-friendly as possible. I already told you how to do it. I'm just going to put reminders on the actual form itself, just in case. And otherwise, I hope you guys have an amazing Monday. Enjoy the nice weather, and I will see you guys on Wednesday.